First few, you're looking for the degree, the leading coefficient, and the zeros. And you're given all these in factored form. So we kind of have some tricks for determining the degree in factored form. So you're just going to look at each of the factors. This factor of x minus 2, the number in front of the x is a 1. Okay. Well, let's do leading coefficient first. So the number in front of the x is a 1. The number in front of the x is a 1. This one, the number in front of the x is a 1, and it's to the second power, so you'll go 1 times 1. So if you multiply all those together, you're going to get 1, and that's the leading coefficient. The degree of this polynomial, well, in factored form, you can just add up all these numbers here. So you have 2 plus 1 plus 1. So this is a 4th degree polynomial. So if you multiplied that all out, it would be pretty painstaking, but that would be a 4th degree polynomial. The zeros, well, in factored form, the zeros are whatever makes each of your factors 0. So take the factor of x minus 2. If you're going to make x minus 2 0, then x is going to equal 2. So one of your zeros is 2, 0. The x plus 6 factor, it's going to take a negative 6 to make that 0. And then the x minus 5 factor, it's going to take a 5 to make that 0. You guys got any questions about that part? Okay. So really, I mean, just pay attention because you're given factored form. You're determining all of these from factored form. We'll get to a section later where you're working with standard form. And from standard form, you're not going to be able to identify the zeros. What's nice about factored form is the zeros are right there. Okay, they also ask us about multiplicity. So multiplicity deals with these exponents right here. So x minus 2, the exponent on x minus 2 is a 1. What was the 0 associated with x minus 2? 2. So the multiplicity of that 0 is 1. Multiplicity. Multiplicity. The multiplicity of negative 6 is 1 as well. And the multiplicity of 5 is 2. Because of that 2 right there. Now the only reason you'd care about multiplicity is because when you go to sketch the graph, if it's an odd multiplicity, your curve will pass through there. If it's an even multiplicity, it'll bounce off.
It's just the exponent, right?
Just the exponent on the factor. Just the exponent on the factor. So now we go to sketch this graph, and you really have a bunch of information to work with. We're not going to get an exact carbon copy of the graph, but we're going to get pretty close. So things I need to know. Hey, this is a 4th degree polynomial. Okay, knowing that it's a 4th degree, it says, hey, basic shape is either this or this. It's a parabola that opens up or down. Now that'd be like end behavior. It might go back and forth in the middle, but if you backed way up, it's going to look like a parabola. The leading coefficient is positive, so it's going to look like that version right there. So don't sketch this one, yeah. But the basic shape is going to be something like, let's say it was something like this. That's going to give you an idea of where to start. So next thing I do is I would indicate where the zeros are on the x-axis. So you've got 1 at 2, 0, 1 at negative 6, 0, you got 1 at 5, 0. So, let's see. We can start this sketch. Remember, it's going to pass through those two, and it's going to bounce off of this one here. So the start of this graph, it's going to be starting from the top. Okay, so it starts from up here. We can erase this one now. It's going to start from the top. Now you have to make a decision. Does it pass through the x-axis at -6, or does it bounce off? It passes through, because the multiplicity, we said the multiplicity of that 0 at -6 was 1. So it's going to pass through. Now I don't know how low this goes, but eventually it turns back around. And we start heading back up to the x-axis. Is it going to pass through at 2 or bounce off? Pass through, because the multiplicity is 1. Odd multiplicity. And it turns around. I'm not sure how high this should go. But at 5, does it pass through or bounce off? Bounce. So you got this curve coming down, basically bounces off the x-axis. Goes up like that. And that pretty much, that matches the basic general shape that we were looking for, which was the parabola. If you backed way up from this graph, it's going to look like a parabola that opens up. So that was a 4th degree polynomial with a positive leading coefficient. You identified the zeros, you looked at where it crossed the x-axis, where it bounced off the x-axis.
So I wrote down it's even multiplicity, then it bounces off, but if it's odd multiplicity, then it goes through.
Yep, even bounce off. Even is bounce. Odd is pass through. Now, do you guys, is it more beneficial today, you think, for me to go over every one, or do like one from every section or 2 from every section? Okay. You guys, you want 1 or 2? Yeah, we can do 4 really fast. Yeah, so we'll do 1 or 2 from every section. So let's go to 4. Okay, 4. What usually gives students trouble is this x right here. X, that's the same. If you'd like, you can write x as x plus 0 to the first. So let's say we were going for the leading coefficient first. So I'd say, well, the number in front of this x is a 1. So it's 1 to the first. So I got 1 to the first. The number in front of this x is a 1. And what's the exponent on that factor? 1. Okay, 1 to the first. The number in front of this x is 1, and it's to the second power. And then the number in front of this x is 1, and it's 1 to the first power. So 1 to the first, 1 to the first, 1 to the second, 1 to the first. So multiply that all together and you get 1. So leading coefficient is positive. So I said this x you can treat as x plus 0 to the first. So the degree on this is, let's see, you got 1 plus 2 plus 1 plus 1. And how much is that? 5. So it's a 5th degree polynomial. So these odd degree polynomials generally look like cubics. So they're either going to be this shape if the leading coefficient is positive, or this shape if the leading coefficient is negative. So basic shape is going to be, we'll erase it, but basic shape is going to be like this. In the middle it might turn around a couple times, and it does. I mean, it's got some zeros, but that's the basic shape. So let's go for the zeros next. What do you guys think is the one that is most often missed by students in this one? 0. Yeah. Yeah, the one associated with this factor, the x, or the x plus 0 factor. Think, what would x have to be if x plus 0 was 0? 0. So you want to list them as ordered pairs. So 0, 0. So 0, 0 is associated with the blue. And then let's go to the green next. So what gets associated with the green one? And if you're struggling with it, just write it out. You're dealing with x plus 5. So write out the equation x plus 5 equals 0. So if you solve for x, you get x equals negative 5. Good job. So that's negative 5 comma 0. When x is negative 5, y is 0. So let me go to the yellow one. So what's the 0 associated with the yellow? 3, yep. 3 comma 0. What's the multiplicity of that? 2. Good job. You're looking up here. Good job. Multiplicity 2. Mult 2. I think the first ones were all multiplicity 1. So then we got one more. We have this purple one, which is the x minus 9. So what is the 0 associated with x minus 9? 9. Yeah, and if you forget, you just write x minus 9 equals 0. Add 9 to both sides. You get x equals 9. And then I would again go to my x-axis and I label those points. 0, 0, negative 5, 0, 3, 0, 9, 0. So we know the general shape. This thing starts from the top and it's got to end at the bottom. So starting from the top, when I encounter that first 0, do I pass through or bounce off? Pass through, okay. And it turns around. What about the next one? Pass through or bounce off? Through. And the next one?
Bounce.
Okay. And the next one? I've kind of said it before. I don't know how high or how low these peaks or valleys are, but they're there. So when you got to calculus, you'd have some pretty slick ways of identifying how high or how low they went, where they were, x-coordinate wise. Okay, so let's go to, we'll do 5 and 8. So for me, when I look at 5, something I notice right away is, hey, 5 is going to be an even degree polynomial. It's definitely even. And the leading coefficient is negative.
Because it's negative, does that mean it's coming from the bottom? Because it's the negative coefficient. It starts from the bottom and goes down.
Well, it's tough to say like starts from the bottom, starts from the top, because like your positive coefficient ones are either going to look like this or like this. So it's like, well, as far as the quadratic one goes, well, it's a positive and it starts from the top. And you'd say, well, a positive cubic starts from the bottom. So I don't know how you want to go about remembering that. But, think if you remember these are the positive ones. So if you reflect them over the x-axis, these are the negative ones. Those two right there. So they don't tell you whether you have to put this in standard or factored form, but I think it's going to be easiest to do factored form because you can see where the zeros are. So your zeros are at, let's see, that looks like negative 4, 0. Hey, if one of your zeros is at negative 4, 0, what's one of your factors? Good job, x plus 4, yeah. Now, what is the multiplicity of that factor, even or odd? Odd, good. So you could do one, you could put a 1, 3, 5, 7, 9. I would just do 1, but it really wouldn't matter. I mean, you'd still get full points if you said it was third. Okay, the next one is right here. So what's that point? 0, 0. So what's the factor associated with that 0? Yeah, x plus 0. I want to put it out front, and instead of x plus 0, I'm just going to write it as x. Is that an even or an odd multiplicity? Odd, good, it passes through. The next one, there's a bounce off, and it occurs at 2, 0. So what's the factor? X minus 2. What would be an appropriate exponent? 2. Okay, and then we have another bounce off at 6. So what's the factor? X minus 6. Exponent 2. Now, hey guys, you could do x minus 6. You could even do 2x minus 12. Because notice 6 makes x minus 6 0. 6 makes 2x minus 12 0. I mean, they would both be appropriate. Now, if you graphed what you had right here, I'm not going to guarantee that it would match up exactly, but it would definitely have those zeros and it would have the pass-through bounce-off behavior. But we're not going to necessarily get these peaks and valleys to the right height, but we'll do that in a later class. Yes, leading coefficient was negative, and we didn't put it there. So here's all you got to do to change your answer to accommodate that leading coefficient is all you got to do is put a negative right in front. On the last assessment, I saw students trying to put like negatives within the parentheses. Just tack a negative to the front of it. So, okay, let's do 8. When I look at 8, 8's definitely odd, and it's a positive leading coefficient. Plus leading coefficient. So what's the next thing, probably? Oh, I think you had it right. What were you saying? X plus 6. So it sounds like you're looking at the x-intercepts. So you looked at that and you said that's an x plus 6. What is the exponent, even or odd? Oh, yeah, odd goes through. Now you see how that goes through, like, we'll be a little fussy here. You see how the way in which it goes through, it looks like a cubic graph? It's not just a straight line. So better than choosing 1 would be choosing 3 here. But if you put any odd number there, it would be fine, but I'm going to put 3. Okay, what's the next 0? 0, okay. So what is your factor to accommodate that 0? X. So what should the exponent on x be? 1. And you see how it passes through like a straight line? Okay, the next one we're going to want to consider is that one. What are the coordinates of that point? Okay. X. What's the exponent on the x minus 5? Bounces off. And then the last one is at 8. 8, 0. So what's the factor? So 8, 0 is a 0. Good job, x minus 8. And what should the exponent be? 1. Now we'll just check. Is this graph going to have a positive leading coefficient or a negative? And in my head, I'm thinking of this picture right here. So that graph right there, does this graph align more to the yellow graph here or the blue graph? It's the yellow, yeah. So that yellow one that's a positive. So we're good. We'll want to have a positive leading coefficient. And we already have that. 9, they give you the zeros. They don't say anything about multiplicity, so they just say, hey, create a polynomial that has these zeros. So take a second right now. I'll put this on pause. See if you could do that. So I'll show you guys my answer. So I have x minus 2, x plus 3, x, and then x minus 1. So notice 2 makes this whole thing 0. So if you plug 2 in for all of the x's, this will turn into 0. If you plug negative 3 in for all the x's, you'll get 0. If you plug 0 in for all the x's, you'll get 0. If you plug 1 in. So you're turning zeros into factors. That's all this problem is asking you to do. Take each 0 and write its corresponding factor. And you kind of did that in the problem before. You guys would say 1, 2, 3, 4, 5. You'd say, hey, this is the point negative 6 comma 0, which is the same as saying f of negative 6 is 0. And then you turn that into a factor. I think 10 is pretty similar, so I'll leave that to you guys. 11 is as well. Let me pause this. Why don't you guys give 11 a try, and I'll put my answer up. Alright, so moving on. Let's do 13. So a 5th degree polynomial with a leading coefficient of 3. So what I'm asking you to really do in A is determine which of these 4 is A. Is it this one, this one, this one, or this one? So purple, blue, green, or yellow. What do you guys think? What does the degree of 5 allow you to narrow it down between what two colors? So these guys here, those are your evens. These are your odds. So it's green or yellow, and the fact that the leading coefficient is positive makes it green. So I'd be fine with this answer right here. If you drew that, I'd know that you were considering the leading coefficient and the degree. At most, how many x-intercepts would this have? Well, if it's a 5th degree, it can cross 5 times. The only way for it to cross 5 times is if there's 1, 2, 3, 4, 5. So look at the peaks and valleys, and if you add up all the peaks and valleys, how many do you get? 4. Oh, and this was, sorry, at most, how many x-intercepts would the graph have? So how many x-intercepts did we draw? We drew 5, 2, 3, 4, 5. So 5th degree can at most have 5 x-intercepts. It doesn't have to, but at most 5. Now, we came from, the first unit we studied was transformations, and what I'll tell you is if you take this curve, and if you slide it up or down, it'll still be a 5th degree polynomial. So think about how you could slide that vertically, still maintaining it 5th degree polynomial. Got a status there. What's the fewest number of times you can get that to cross? 1. So at least, it's got to have at least 1 x-intercept. Now if it was an even degree, the even degrees, those U-shaped ones, you can slide a U-shape so it's never going to cross the x-axis. So in the problem before, where it was an even degree and it says at least, the answer would be, well, it could have 0. And then we answered the max-min questions. If you just loop that thing, if you're drawing it and it crosses 5 times, you'll notice that there's a maximum of 4 peaks and valleys. Doesn't mean there has to be, but that's the max that it can have. So kind of some of the shortcuts here. This answer, D is always 1 less than the degree. B is always the degree. And the shortcut for C is 1 if it's odd, 0 if it's even. Alright, so go to matching, but notice all these polynomials are not listed in factored form, they're listed in standard form. So, this says, hey, use end behavior, which says use the concept of the degree and the leading coefficient. Don't worry about where it crosses, but just look at the basic shape. And, basic shape is really these 4. So using these 4 as your guide, determine which goes with what. So number 1, the purple, the blue, the green, or the yellow? Number 1 is the purple. Number 2 is good. Number 2 is yellow. Number 3 is blue. And number 4 is green. So what does it take to build one of the purple graphs as far as degree goes? Even or odd? Even. So which of these, now when they're given in standard form, all you guys care about is the highest power of x. So you only need to concern yourself there. So which of those has an even degree? A, B, C, or D? Or which? A or B. Okay, so we know the answer is A or B. Now, one of them has a negative leading coefficient, one of them has a positive. So is the purple, is that a positive leading coefficient or a negative? Positive, so the answer has to be A. So A is number 1. What do you suppose that B is, knowing that it was one of the evens? 3. And C, should C look like the yellow or the green? Yeah, C should look like the yellow, which we said was number 2, and the green, which is number 4. Cool. Okay, I'll pause this and I'm going to pull up the 5B assessment.